Hello, my name is Richard Grocott and I'm the Export Sales Director at Bowers Group. Today I'm going to show and demonstrate our air gauging system and explain what it is, how it works and what Bowers Group can offer. I'm going to talk about the general use of air gauging, the equipment that you need to get started and the display options that Bowers Group can offer. So air gauging is a very simple, fast and user-friendly method of providing high precision measurement results, even in very challenging environments, by providing a non-contact measurement system that uses airflow volumes and pressures to measure components. And we know that air gauging is a very reliable and repeatable technology that is well suited for applications that demand sub-micron precision. So let's take a look at it in its component parts, and we can see that an air gauging system consists of an air plug or an air ring with an air supply through a precision regulator and filter kit, high and low setting masters and a digital display. We have 3 displays which we can offer. All of them are capable of data output and can facilitate an inspection plan. So air gauging is perfect for geometric measurements such as straightness, concentricity, hole center distance, taper, and much more. There's virtually zero operator influence, and this ensures that you can get excellent gauge R&R capability. Each air plug or ring is machined as a bespoke component at our factory in the UK, and to ensure that we provide the best solution, we would normally require an engineering drawing of the part to be measured. So, how does air gauging work? Well, most applications use back pressure variations to make a measurement, and as distance increases, the back pressure decreases. This is known as inverse proportion, and we can tailor the jet configuration to guarantee linearity over the required working range. Our air gauging systems require a minimum of 2 setting masters. These masters are produced at the upper and the lower tolerance points, and in most applications those are the critical points, but our readouts also have the facility to use 3-point calibration, which is useful in applications where a larger working range is required. Air gauging offers a very simple and easy to use system, giving operator confidence that they are producing a perfect part. Bespoke designs give reduced measurement cycle times and help to avoid any expensive scrapping of customer parts. With air gauging tooling, you'll need a digital display. We have 3 displays available, starting with the Bowers Air 1 and Air 2, which are single and dual channel units. These can be configured manually using the touchscreen or using a QR code, and the QR code normally is preloaded with the correct measurements and tolerances. And the QR scanner simply plugs directly into the display and doesn't require any external hardware, just the QR scanner itself. The number of channels determine the number of inputs on the back of the display. So Air 1 has 1 tooling input, Air 2 has 2 tooling inputs, and they offer a range of measurements going straight into Excel or any other system that you may use. A MIDI printer is also available for printing. And to maximize efficiency when taking measurements, a configurable foot switch can also be provided. Our Air 3 display has the same features as the Air 1 and Air 2, but with a larger screen and some extra features including sequence measurement for a guided inspection process and a nice eco mode which reduces air consumption during periods but maintains some airflow to maintain the tooling in a good condition for when measurements need to restart. It also has SPC function, so for machine tool analysis, and is network compatible because it's a non-Windows operating system. It can be networked. And our digital displays are also configurable with Silcom software from Silvac and through MBus modules. That can be used to create inspection plans, capture data, carry out post-measurement SPC operations, and so on. Okay, I'll now show an air gauging sequence measurement demonstration. And this demonstration will show how 6 characteristics of a part can be measured. This is actually can be done as a manual process with the tooling auto-detecting, or as an operator-guided measurement sequence, which is what I'll now use. The first request when using a sequence measurement is for the part number, and I can add that using the QR code scanner, and that's followed by the number of parts in a batch being measured. I'll add 2 parts for this demonstration. Now, as I run through the guided sequence, each measurement is displayed and captured, and I've set up a foot switch to cycle through each of these measurements. One part of the sequence is a manual input of a visual check. It's actually looking for a drilled countersink, which I'll confirm as being present. Move on to the final 2 measurements. When I've completed the part measurement, there's a summary screen, which shows all of the results, all of the fact that they're all good results within limits. If I hit OK at that point, it will transfer the data also to an Excel spreadsheet. We're moving on to the second part, so we're part number 2 of 2, and go through the same process, cycling through each stage of the check. But this time, on the visual inspection, it's looking for this drilled countersink. I'll actually say that that's not present, so we get a no-go result in this case. Final 2 measurements. Now we have a summary sheet that's showing that everything apart from the one visual check that I made is okay.